When we discuss electrical current, we are referring to the rate of charge flowing through a system, and we measure it in units of amperes represented by capital letter A. 1 amp is the flow of 1 coulomb of charge per second. Since 1 electron has a charge of 1.602 times 10 to the negative 19th coulombs, 1 amp is the flow of 6.242 times 10 to the 18th electrons per second. Electrical current is driven by potential difference, which is the difference in potential energy in joules per unit of charge in units of coulombs. This potential difference is measured between two electrodes. The potential difference is given in units of volts, where 1 volt is 1 joule per coulomb. A large potential difference indicates that there is a large difference in charge between two electrodes. This means that there is a strong tendency for electrons to flow, and therefore it would be a spontaneous process. For voltaic cells, this potential difference is called the cell potential, represented by E with the subscript cell. It depends on the relative tendencies of the reactants to undergo reduction. Cell potentials also depend on the concentrations and temperature. For standard conditions, which would give us standard cell potentials, all gases must be at 1 atmosphere pressure, and all aqueous components must be at a concentration of 1 molar, and the temperature would be at 25.0 degrees Celsius. So for example, if we have the redox reaction involving zinc metal and copper ions reacting to form zinc ions and copper metal, this redox process has a standard cell potential of plus 1.10 volts. However, if we were to replace the zinc with nickel metal, then the nickel metal reacting with copper ions to produce nickel ions and copper metal electrochemical cell would have a standard cell potential of plus 0.57 volts. Since the second example has a smaller standard cell potential, this means that the zinc metal has a greater tendency to be oxidized than does the nickel metal. A negative standard cell potential indicates that the forward reaction is non-spontaneous. Therefore, for voltaic cells, which require that a spontaneous reaction be in place, all standard cell potentials for voltaic cells must be positive. By now, you should be able to define electrical current, including the common units. You should also be able to define potential difference, including common units used for potential difference. You should be able to define cell potential, E cell, and standard cell potential, E0 cell. You should be able to use standard cell potential values to identify which reactants are more likely to be oxidized. Finally, you should be able to describe the relationship between standard cell potential and spontaneity of an electrochemical process.